So the goal for today is to be able to factor polynomials by GCF at 80% accuracy or higher. So that's what this whole unit 7 is all about, is factoring polynomials. The last unit was about operations with polynomials. So factoring is kind of like the opposite. So we'll discuss that in a little bit. But to be successful at this, you need to be able to break down numbers into their prime factors, identify common factors between each term, and then divide each term by the GCF. I'm recording now. I'll link it in the slides just like I always do. But here's a couple shorter videos that I found that are also helpful that I did not make. And then if you want to watch the one from last year, go ahead. It's pretty much the same lesson. The practice you picked up on the way in, so it's a worksheet, evens or odds. So far, all my classes have had at least 15 to 20 minutes to work on it. So whatever you don't finish needs to be finished by the time you walk into class on Monday. So whatever you don't finish is homework. Because on Monday, we're just gonna review the answers and do the exit ticket. So make sure that you're prepared for it by practicing it if you don't finish practicing today. Toward the end of class, I'll check binders for anyone who has not yet turned it in, or maybe you took some note papers and said you were gonna do them. So if you have them ready today, I'll check them. I'm not really one to remind you every day to show them to me. If you never show them to me, that's kind of on you, like you have to remember. So just, some people weren't in here the day I checked them, so I'll check those today. All right, so here's the schedule for assessments next week. We're looking at benchmarks toward the end of next week, so be aware of that. Any questions? All right, so now on to the note sheets. Starting with the warm-up. So we just took a test on this. I'm hoping this is fresh in your mind. How do you solve these? You distribute. Good. So you take the outside term and multiply it by both of the inside terms. So what's A times 3A? 3A squared. Good. 3A squared. What's A times 7? 7A. And it's positive, so make sure you put plus 7A. Sometimes we have to combine like terms on problems like these where you're just distributing. Usually you don't. All right, then on to the next one. So now there's 3 terms that we have to distribute to. What's negative 2m times m squared? Good. What is negative 2m times positive 6m? Good. Don't forget that m squared. And negative 2m times negative 1. Positive 2m is correct. All right. Questions on that one? All right. Last one. Remember, do the coefficients first. What's the coefficient if it's not written? So 4 times 1 is. And then we have x cubed y times x squared. What do we get? Good. X to the 5th, y to the 1st. All right, so this one didn't have a y, but you still put it there. It's kind of like multiplying by 1. All right, now what's 4x cubed y times negative 2y? Good. Questions on the last one? So more stuff involved. When we multiply, we use the product rule. We add the exponents of the same base. All right, and the reason why this is our warm-up is because on our last test, the questions that we were given looked something like what's on the left, right? And our answers would look something like what's on the right. Well, now for this next test that's coming up, it's the opposite. So our questions will look like what we have here for our answers, and we're going to be told to factor it. So to get these. All right, so it's kind of like working backwards. That's what factoring is. So what is factoring? That is separating a polynomial All right, separating a polynomial back into a product. All right, separating a polynomial back into a product. So the warm-up, if you kind of look at these as what you're given and these as our answers, that would be an example. Here's another example. So simplest form could be 4a squared plus 8a. Factored form, and we'll tell you how to factor later, will be 4a outside parentheses a plus 2. All right, so simplest form would be what you get when you distribute. Factored form is what it looks like before you distribute. That's what we'll be doing, is getting it into the factored form. So there's a ton of ways you can do that. And today we're going to look at factoring by GCF. The greatest common factor. I'm hoping that is familiar to you, the word GCF. You might have forgotten what it is. That's okay. We'll remind you. But first thing you're going to do, and we'll fill in this blank later, by the way, but here's some steps for factoring a GCF. First thing you're going to do is look at the coefficients. So what's a coefficient? The number in front of the variable. So we're looking at the number in front of the variables. If you don't know that, write it down. Hopefully you do, since it was on your last test. All right, but coefficients are the number in front of the variable. So if we look at our example up here in simplest form, what are the coefficients? 4 and 8. So first we'll look at the coefficients and look for a GCF between those. All right, I'm sure some of you can do it without having to make a factor tree. But if you're ever unsure, make the factor tree. So break it into its prime factors. What are prime factors? So like is 2 prime? Is 3 prime? Is 4 prime? Right, 4 is not prime. So prime are numbers that can't be broken down any further other than 1 and itself. 4 can be broken down into what? 2 and 2. So that's why 4 is not prime. When we're making our factor trees, we break it into its prime numbers. You're done once the numbers on the end of your trees are prime. All right, so what goes into 8? 4 and 2 is 4 prime.
No.
What goes into 4?
2 and 2.
And then it's 2 prime.
Yes.
So then we're done making our factor tree. So we look for a GCF between the two. If it's not easy to see, you could do this, make a factor tree. And then what we did in elementary school was after we made the factor trees, we listed out the prime factors. We looked for common ones between each list. So like here's a pair of 2s, here's another pair of 2s. For each pair, write it once. If there's multiple pairs, multiply them together. So our GCF between 4 and 8 is 2 times 2, which is 4. All right. So that's how you find a GCF between numbers in case you don't know. Questions about that? All right, so what if there's no common factors between two numbers? So polynomials that cannot be factored would then be called what if they can't break down in here? What's that word when it can't be broken down into? Good. So polynomials that cannot be factored are called prime. So now we can fill in that blank. So if you can't find a GCF, then it's prime. It can't be factored. All right, so we just covered the coefficients. That's probably what you're used to, is finding the GCF between numbers. But we're also going to look at variables. So variables, in order to factor them out, they must be present in all the terms to be part of the GCF. If a variable is present in all terms, take the one with the smallest exponent. So if you look back at our example in simplest form, oops, hold on. Hang on one second. If you look at our example for simplest form, is there an A in both terms? So that's why A is part of our GCF. Is there an A squared in both terms? Is there an A squared in this term? So that's why A squared isn't part of our GCF. It's whatever one has a smaller exponent. Yes? Yes. All right, so that's how you determine if a variable is part of your GCF. It has to be present in all the terms. If there's multiple, take the one with the smaller exponent. Lastly, once you identify your GCF, that will go outside the parentheses. Inside the parentheses is what you get from dividing each term by the GCF. And then you can always check your work by distributing. So if you distribute and get what the original problem was, and you know you factored correctly. All right, so let's put all those steps to use. So number 1, look at your coefficients. I have 3 and 12. We could make factor trees for both, but here's another little tip for you. Always look at the smallest coefficient, so the 3. If it can divide evenly into the other number, then that's the GCF. So can 3 divide into 12? Yes, so 3 is part of my GCF. If it can't, then I would probably make a factor tree of the 3, but it does divide into the 12. Can I take an X from both terms? No, because they both don't have X's, so that means just the 3 is my GCF. Right, and that will always go outside the parentheses, your GCF. Now, inside is what you get from dividing each term by the GCF. So first we'll do 3x divided by 3. What do we get? Good, because if you have the same thing on top and bottom, they cancel out to 1. So I just have x. And then what about the 12 divided by 3? What do we get? 4, and it's positive, so put plus 4. And if I were to distribute, would I get what the original problem is? Yes. So then that's how I know I did it right. And I'm drawing these arrows for the notes. I think that would be helpful, at least on this one, to see where you got all the numbers. But what's in blue is your answer. So questions on number 1. All right, let's look at 3 together. We have an 8 and a 36 for the coefficients. What's the GCF between those? Is it 8? Can 8 divide into both of them? Not into the 36. So if I wasn't sure, I can make a factor tree of the 8. Hold on one second. I can make a factor tree of the 8. And what goes into 8? 2 and 4. I know 2 for sure goes into both, but you want the greatest common factor. Can the 4 go into both? So that's part of my GCF. Making sense? All right. Can I take out an M from both terms? And I take out an N from both terms. So that's why 4 is just my GCF. Questions about that? So your GCF will go outside parentheses. What's inside is what you get from dividing by the GCF. So what's 8n divided by 4? 2m. And then what's 36n divided by 4? 9n is correct. And it's positive, so that's why I put plus in the middle. All right, questions on number 3. And if I were to distribute, would I get the original problem? Yes. So then I know I did it right. All right, you guys try 2 and 4 real quick. And then I'll project those in about a minute. So for 2, you should have had 7 as your GCF in parentheses, y minus 1. 4, you should have had 5, and then in parentheses, x plus 6y. Questions on this one, on these 2? All right, so those were like the easier ones. There was just a GCF on the coefficients. So now let's look at the other kind, if I can close this. So on the back side, let's look at 7 together, number 7. All right, our coefficients are 21 and 3. Look there first. Always look at the smaller number, see if that can be your GCF. So does 3 divide into 21 evenly? Yes. Yes, so no factor tree needed there. Also, keep in mind, I have seen it like on tests, multiple choice ones. Sometimes they factor out the 3. Sometimes they factor out a -3. Just know that both can happen. There can be like 2 right answers. So if they factor out a negative, then the signs will be different versus if they factor out a positive. All right, but we'll just keep it positive on this one. Can I take a C out of both terms? Can I take a D out of both terms? So then my GCF is 3D. Questions there? All right, what we get on the inside of the parentheses is what we get from dividing. So 21 CD divided by 3D, the GCF. What's 21 divided by 3? 7. And C divided by 1, technically. C. And D divided by D. It cancels out. So I just get 7C from dividing by the GCF. Then do the -3D divided by 3D. What do we get from that? -1 would be correct, right? Because if you have the same thing on top and bottom of a fraction, it cancels out. But so the 3's cancel, the D's cancel, but we still have a negative. And remember, when stuff cancels, it cancels out to 1. So that's why it's a -1. So don't put 0 when something cancels out. Questions on number 7? All right, so then we're going to scroll down and look at 13 for a second. So number 13, I have 5 and 13 as my coefficients. What's the GCF between those? 1. And do we really ever factor out a 1? No, because that doesn't change anything. If I was really unsure, I would see that from my factor trees, there's no other GCF other than 1, right? So then look at your variables. Can I take out an X from both? Can I take out a Y from both? So what would I write as my answer? That is correct. When you can't factor it, you put prime. Questions on 13? Yes. All right. 18 we'll do together. I want to do some where there's like 3 terms. So look at 18. Look at the coefficients for 18. We have 12, 36, and 6. You need to find a GCF that fits for all three of them. So what do you guys think it'll be?
6.
6. 6. Some people in the other class said 2. Some people said 3, which do work. They do divide into all of them. But 6 is the greatest one, right? We want the greatest common factor. So it's 6 that we're dividing out. Can I take out any of the A's?
Yes.
How many of them? So they all have A's. If they all have A's, take the smallest exponent, which would be 2a squared. Good. So we're going to take out 2 A's from each of them. Can I take out any B's?
Yeah.
How many? 2, because they each have at least b squared. Questions there? So that's my GCF. Now we just need to divide each term by the GCF. So 12, a to the 5th, b squared, divided by 6a squared, b squared. What's 12 divided by 6? 2. A to the 5th divided by a squared. Good. And b squared divided by b squared. It cancels out. When it's exactly the same on top and bottom, it cancels out. Now the next one. So negative 36, a to the 4th, b cubed over 6a squared, b squared. So it's negative 36 divided by 6. It's not negative 4. 6, not negative 9. Oh, negative 6. All right. And also keep the signs that are in front of each term. So that's why I put negative 36. There's a negative here. That's why it's a negative 6 here. Now a to the 4th divided by a squared. A squared. And b cubed divided by b squared. Good, just b. And then the last term divided by the GCF. So what's negative 6a squared b squared divided by 6a squared b squared? Negative 1 is correct. Right, same thing on top and bottom, makes it cancel out, but we still have that negative. The negative didn't cancel, so that's why it's a negative 1. Questions on 18 or any of them? All right, I'm going to give you some to try. It's going to be 17, 19, and 12. So you try 17, 19, and 12. Depending on how those go, then I'll let you start the practice after. I'll give you about 3 minutes. All right, so number 12 we'll start with. What are the coefficients on 12? 3 and what if it's not written?
1.
And is there a GCF between those other than 1? No, so then you can't factor out a coefficient or a number from the coefficient. Can I take an X from both? How many? And can I take a Y from both? How many? So your GCF should be XY. Make sense? All right, so then divide each term by XY. What do you get from 8 squared Y divided by XY? Just X, good. And what do we get from 3XY divided by XY? Just 3. And it's positive, so make sure you put plus 3. Questions on 12? All right, so sometimes if it's the coefficients, you can't factor anything out, but if there's variables, then you still can factor those out. So don't just say they're prime unless you can't factor out anything. All right, so scrolling down to 17. So here's my coefficients for 17. What's the GCF between those? Is it 6?
No.
So then if I make a factor tree, 2 and 3, is it 3?
No.
Is it 2?
Yes.
So 2 is my GCF. What about the y's? How many can I take out?
Y squared.
Y squared is part of my GCF. All right, most I can take out from each one is 2. So I'll use a smaller exponent. All right, then divide them. 6y to the 4th divided by 2y squared. What's 6 divided by 2?
3y squared.
Good, I get y squared, good. And then 14y cubed divided by 2y squared gives me what? Positive 7y, good. And lastly, negative 10y squared divided by 2y squared. Good. Again, keep each symbol that's in front of each term when you're doing your dividing. That's why it's negative. It's negative 10 divided by 2. And these cancel. Questions on 17? All right, if it's all right with you, I'll just project 19 and see how that went. So 19 is shown here. So you should have found that 14 was the greatest common factor, not 7. I know maybe at least someone in here said 7. Yeah, 7 goes into all of them, but you want the greatest. So 14 would be the greatest. And then you cannot take a G from each term because the last term doesn't have a G. But I can take at least one H from each term. So that's why it's H to the first. Divide it from each term. So this one divided by 14H gives me GH. This one divided by 14H gives me 2G because the H is canceled. And then 14H divided by 14H cancels to 1. And it's positive because both the 14s here are positive. Questions, comments, concerns? All right, so that gives you about 20 minutes to do the 7-1 practice. I do have the key posted on the back wall if you want to see if you're doing it right. I'm here if you have any questions. Do not use algebra problem solvers on these, please, and thank you. All right, you can do them yourself. It'll help you in the long run.